it is Doscember. Today we will be creating raster bars or a raster bar. The code for this one is in the description, but that would take a bit too long to explain. It's going to be a lengthy one already. Motherfucker! So raster bars are quite simple. It's actually the electron beam that scans from left to right, and at a certain position we say change the background color to red, for example. And we wait until it hits the horizontal refresh, and as soon as it does that we turn it back to the background color black, and we continue, and then you have a single red line. And then you can build up that, you can expand that red line to make it a bar, you can gradiate it, and that is exactly how I will be coding this. We will take these little steps. The first code block is quite substantial. I will speed up here and there, but it is important to really grab the concept. Now, the code for my DOSBox environment can be found below, as well as, of course, the raster bar GitHub. And yeah, let's jump in and have some fun. I will start with TC and I will call it raster.asm. And let's remove that top one, that's an old file. Okay, we first need to set up the model. It's a model tiny. We're not going to use any more than 64 kilobytes. Tiny. We put the stack at 100 hex. And here we're going to define a few variables. Pellet index EQ 3CHA. That is where we can find the colors in the VGA register. This is the port number 3C8. Then we have the data, and the pellet data with the three colors, the R, G and B, is located at address 3C9 hex. And then we have the input status register that we need to read. That is on 3BAH. We have the horizontal retrace that we wait for when we are coloring a line. That is offset 1 in that input status. And we have the vertical retrace, and that is offset 8. That should be it. Then we create a data segment, and we need some data for the red. Let's call that R. We need a variable for the green. Let's call it green, and for the blue. And then we do a code segment. And there I will include a file. I will show that a little on. It's just a simple little function. Standard func.asm. And this waits for the key pressed. Include is used for key press. I use that so often. And then we have the main proc. And we have the main end proc. Right. So the first step is to initialize all the data. Initialize the program. Let's set the segment data. Move AX segment data, and then we set AX to DS. That sets the data segment to where the data is located, which is currently the code segment. And we will set the line that we're going to draw will start at 100. Line where to start. Raster line. Okay. Then we have a nice little loop that we jump to. Now we first create a method to wait for a vertical retrace. We need to go back to the top of the screen so that we can start counting the lines. Let's call this vert retrace and let's create that function. Vert retrace proc vert retrace vert retrace and p. Wait for vertical retrace. First we clear the interrupt. We don't want any interrupts while we're actually waiting for the retrace, otherwise we could miss it. And this is a very fundamental change from all your other platforms like the Commodore 64 and Amiga, where you could set a raster interrupt, and on this line it would trigger an interrupt in case of the Commodore 64. We actually have to wait in software. It's not really efficient, but that's the only way to do it in VGA. So we need the input status register that we declared up there. And let's, for the vertical one, we're going to read in does read a port, so we read the input status register and we end it with the vertical retrace number that we defined. And when it's not set, we need to go back to V1. And we actually need to do that twice in order to know when it's actually on the top. In AL, DX and AL, vertical retrace. And when it's at the top, it will actually be a 0. And then we return. So in short, as soon as it hits, we are looping until it hits, and that is the not 0, and then it moves back, and during that position it is 0 until it's again on the top, and then obviously the data is no longer 0. So now we can call the retrace, and then we can set the CX to 0 FFF. I set it to -1 or FFF because the first thing that we're going to do is increment it, and that starts at line 0. Otherwise we're off by 1 and we get weird shit. And now we can wait for line. And now we need to wait for the horizontal resync. Then we know we are on that line. Horis, retrace. And let's create that function as well. Horis, retrace, proc. Horis, retrace, and proc. And that's a sort of a similar process. Wait for Horis, retrace. We need to move the same input register, input status in the X. Then we also we need to clear the interrupts first. Clear the interrupts, same problem. And we call this H1 for horizontal resync. We read in the status information. We end that with the horizontal retrace flag. Jump not 0, then we go to H1, H2, in AL, DX, and AL, horizontal retrace, jump when it is 0 to H2 and return. We need to copy that standard function. DOSBox here. So I have this file called b.bat that will compile it. And there is an error, can't locate std func. I made a typo there. And I see another typo, input status. It is always important to compile assembler in between to not have too many problems at the same time. B raster, and there is something neat expression in 14 and 73. Everybody already saw that, but we are typing. And I forgot something. Did I put an end main there? I did not put an end main there. B raster. Okay, yeah, something is happening. And we're not calling the clear line. That is perfectly problematic now. But it's compiling. So we're waiting for retraces and everything, so that's good. Now we wait for the line, right? Let me think for a second. We need to increment the line counter. Increment X, increment CX, increment line counter. We need to compare CX to BX. If line counter equals to bar line, then we know that we have to draw the line. And if it's not, then we wait, jump, underscore wait for a line. So basically we're just looping here for each line until we hit that line number. So what we're doing in this section is the electron beam is scanning a line. As soon as it retraces and it's back, we increment the CX, so the line counter that we're then in. We compare the CX with BX, which is the line that we want to draw the bar on. When it's not the same, we continue, so we continue to count the lines until it hits 100 in this case. Yeah, that's right here. And then we jump out of this loop. And then we can draw the line. So let's draw a nice and bright line. I use AL for this and set it to 60. It is 0 to 255 for each RGMB. And let's make it a red for now. So we just set AL. And then we call draw raster line. Raster line. And after we're done, we need to set the raster line to 0. And we set R back to 0. Later on we will create a white bar, but red is nice and simple. And let's create this function to create the bar. So that is called draw raster line proc draw raster line NP. Okay. So first we need to set the pellet index for the VGA, and we have a variable created for that. It's called pellet index, and I believe it was 1L. Pellet index in DX, because DX is the only register that can be used for in and out. and we set AL to 0, and we instruct with an out, then we're writing 0 to the pellet index, preparing to actually receive colors. So we have set here the pellet index to 0, basically instructing it that we will be sending it pellet information or color information. So first we set the R value, so we read from the R, that is the one. We first read from the R variable the value that we're going to put into the pellet data. So move dx, pellet data and out dx, al. So technically I wouldn't have to reset dx with pellet data, but I do that for legibility, and since we're wasting already cycles waiting for a scan line, then readability is more important. You can always take it away when this is an issue, but I never had that issue. And the same here for the blue. Read the byte pointer blue into AL, and then we put the pellet data data into that port. And then we need to wait for a horizontal refresh. Retrace. And then return, and that should be it. So basically what we now have set is the background color for the pellet to the color that we have set. So it will start to create a red line. Let's make sure that these are 0. Yes, these are 0, and this one we set to 60. Okay, so it would be drawing a bar. And then we need to enable the interrupts again, because we disabled them in the vertical resync and the horizontal resync. STI does that. And we have to do the key press exit. This is the function that comes from the standard func library that I created and included. It is called exit, I believe that I called it. And otherwise we jump to loop. And this should be it to write a raster bar. The raster. And we have an error. There's always an error. Undefined pellet index pellet data. Knowing me, I wrote pellet wrong. Yes, of course I did. Pellet. And what is here? Pellet data. There I still do the double L. You guys wouldn't warn me from all my typos, huh? No, let him figure it out. And there's still one error. What is it? Undefined pellet data. Oh, there was one with one T. Brilliant. I am very dyslexic, and that's no joke. So I sometimes don't see those nuances. We got a whole red screen, so we're missing something here. So we're turning on the color, but we're turning it on too early. Let's see what this is. Or we're turning it off too late. And oh, I see what I'm missing here. We need to call the draw line, because we need to draw the rest of the lines in black. Or the background color that we want, and we set that to black in this case. I think this should solve it. And there we have it, a nice little raster bar. And you can see that this isn't a graphics mode, because the text is still on the screen, and it's truly only the background color. So just to reiterate, we're waiting for a certain line, we're counting the horizontal resyncs, and when we hit 100, it's like, oh yeah, let's set the pellet data, and let's first load the pellet index into the VGA register, and then the pellet data to set the background color. It will write that red color, and as soon as the horizontal retrace is there, we're setting it black to 0, and it continues black to 0. And here again, oh, it's 100, let's draw it black. And after that, oh, there's a resync, we set it to 0. Now we're going to make the bar a bit wider. So let's jump back in the code and introduce a new variable. Let's call this bar width. And let's make this 10 long. And basically it's really easy. We need to reiterate this the amount of times that the bar is wide. I think we're going to create a bar. Let's remove this, because I like to have little functions. And let's call Drawbar. That makes me think of a Hammond organ. Drawbars, those handles that you pull out. Drawbar. Drawbar. NP. Okay, let me think. We first again need to set the color that we want. We want to have a red color. Basically just copying what we had, but now in a nice little function. Then we need to call the draw raster line. So we're basically from the bar calling the draw raster line, and here we will iterate this the amount of times that the bar is wide. And then we have to still wait for the horizontal retrace. Decrement AH. I will set the size of the drawbar of the bar in AH before we're going to call this, because then we can parameterize it. So let's put it here. AH will contain the width of the bar. And then we decrement it. When it's not 0, we're going to jump to bar lines. Let's create a variable bar lines here. And in that case, I need to move into AH the bar width. Or actually what we could do is, that would be a better choice. Control. Let's move this out of here. Move AH, bar width. That is a cleaner approach. Right, and that should actually draw the bars, right? We're going to loop, going to decrement. Yeah, that should be it. Let's do a raster. And we got an error. Of course, there is always an error. I'm doing the same thing wrong. Of course, I need to set the color back to 0. And we need to draw a raster line as well. Same mistake as before, and I need to do a return. So now we should have a raster bar that is 10 pixels wide. There we go. Now the next step is to actually shade this, because this is not nice, this is amateurish. So let's start shading this thing. Right, let's do some shading. So for shading, the easiest way and the fastest way is actually having a lookup table. It's basically an array or an index, how you want to call it, with the colors that we want to put on there for each of the steps. Now we have 10 steps, so let's create a bar pellet. Bar pellet. Did I write it correct this time? Yeah. And let's do 10, 20, 30, 40, 60, 40, 30, 20, 10, and a couple of extra nice dark ones. These are 11 and we start counting from 0, so that's correct. I'm going to use a couple of extra registers that I want to save. Push AX. And then we always need to pop them before we continue. Pop AX, pop SI. Move AH, comma, A. Actually, SI, sorry. Move SI, comma. In AH is where we have the width, and I'm going to need that. I need to go count down from that. I could actually use AH for that itself. No, because I need an offset. So I need SI or DI. So move AL, that is the shade now. So we're not going to use this anymore. And we're going to use a byte pointer, and we read that from the Bar Pellet and from the SI index. So we have SI now set to the number of lines, and we're going to fetch that number from that pellet. Yeah. So we're basically going from the back to the beginning of the bar. So here we're starting with the dark, and then we're moving back to the somewhat lighter, so from right to left, because the index set is to 10, and here we say, where is it? Here we say that the bar width is AH, so it's already set to 10. And here I set that 10 in SI, because SI is typically an index register that we can use here. And then I read that byte, set it in AL. That should be good, right? Yeah, that should be good. And I think that's about it. We need to decrement it. If we decrement SI, at a certain point it hits 0 and it falls through. So this should be a shaded version. Oh, there's an error. And there is always an error. Bar Pellet. Bar Pellet, how did I call it? Bar Pellet, B-A-R-P-A-L-E-T-T. Bar Pellet, yeah. My dyslexia. Dyslexia. There we go. And there's another. What did I do wrong? 56 types of operands don't match. Move. Oh, hang on. AX. AO to 0. Oh, hang on. That is a nice one. Let's move AL, AH into AL, and then we have to reset AH. Let's do an XOR, that's quicker, to 0. So here we copy AH to AL for the lowest number, because we need to put AX in the SI. And here we clear AH, effectively transferring. I could also have shifted it, of course, 8 bits, 8 times. AH to AL. And this should then work, but those are my less famous words. And there we go, yes! So what we did now is we created a single line, then we created a nice single color bar, and now we have a nice gradient bar. All we now have to do is create a up and down motion, so let's do that. There is this website that allows you to generate sine waves. Let's go back to the beginning. I want 256 values. And the maximum value is 370, that's the amount of lines that we have, and we want 16 positions, and it generates a nice little table. So So I already have the table here converted to our format. I removed all the leading commas and set DW because it's a 16-bit value, a word, in front of it. And that will need to be copied into the source code. Since we're not going to be able to copy straight in there, I will use a little trick. I will open a secondary window, go to my directory, x86, code, bars, oh it's capitals of course, raster.asm, and let's plonk it right in there. So we have the sine wave, yeah, and let's do the Ensign label. So I can calculate the size of this table. So if you want to make it larger, then still everything will work. So let's go and implement this. First we need to set bx to, it's no longer here. We need to move it inside the loop. bx, that contains the line number where we want to start drawing. And we need to transfer a word because it's 370 max, so it's 8 bits. And we use DI for that. I think that is good. Then we need to, of course, set DI to 0. So here we have that first value from that massive table. From that table we have the first value. And we need to it will actually wait there. Yeah, that's perfectly fine. That will work. Then we need to add 2. Move to the next index in the table. 2 because it's 2 bytes in total because it's a word. Then we need to compare DI to sine end minus the sine table. So I subtract the address where the table ends from the address where it starts, and it gives the number of bytes that it is in total. And otherwise, continue to look the table, yes, and otherwise we must reset DI. No longer within the table. Reset DI. Okay, do I need to do something else? No? Then we can just continue the table here. Let's make this consistent with an underscore. I use underscores for methods that are within a procedure. It makes it a bit more legible. Okay, yeah. This should technically work. Let's see if my brain force actually works. B raster 4. And there's an error. And there is always an error. Sine ain't. Ensign. Oh, I call it Ensign. Then we're calling it Ensign. And Sine. There we go. So let's set all the colors. Then we also need to reset them all, of course. And now we should have a nice black background. There we go. A nice raster bar. So I noticed when running this that we see a little flicker here in the center. Bloop. Now this is indicative of something wrong in the table, or more likely in my code. And I say jump less than or equal, but it should be set jump not 0. Yes. And that should fix it. So there you have it, a nice raster bar running on a real 486 written in assembler on DOS. Yeah, And even though it's a bit of a hassle on VGA compared to the Commodore 64 and Amiga, it still really is a nice little effect. And you can go a bit overboard like I did here. The code is actually in the description. It's called T4.asm. That code isn't as nice as we have just written there. There's no subroutines. I hacked it together in a couple of hours when I watched Root42. Check out his channel. He does some really crazy stuff. And he wrote this in C, and I figured if you can do it in C, I can do it in assembler. So check out that code as well. But this is the clean code. Now I hope you learned something, and I hope to see you in the next one when we do a star field in assembler on DOS for Doscember.